In this lesson and experiment, students make rubber from Elmer's white glue. They will also learn about the chemistry of this transformation. Polymers are very large molecules made up of a chain of smaller molecules bonded together. The small molecules used to create polymers are called monomers. The prefix mono means one, while poly means many. Most polymers are made of organic compounds that contain the elements carbon and hydrogen, but they also often include oxygen and nitrogen. Polymers form when chemical bonds link large numbers of monomers together in a repeating pattern. Think of polymers like chains of many paper clips connected together. This is why chemists often call them polymer chains. Each paper clip would represent a monomer molecule. When two different monomers combine, they form a copolymer. The red paper clips in the diagram represent one type of monomer while the green paper clips represent a second, but different monomer. Elmer's glue is a mixture of water and a polymer called polyvinyl acetate. The long chains of the polymer can slide past each other, resulting in a viscous liquid. This diagram shows the structural formula for a small section of the polyvinyl acetate chain. Now let us see how the glue becomes rubber. Borax has the chemical name sodium tetraborate and the chemical formula Na2B4O7. In the first step, it dissolves in water and splits into two compounds, sodium hydroxide, NaOH, and boric acid, H3BO3. These two compounds react together immediately to form positive sodium ions, Na+, and negative borate ions, BOH4-. In the second step, shown in the diagram, the borate ions react with polyvinyl acetate to form polyvinyl alcohol and acetate ions. Note that the polyvinyl alcohol has a hydroxy group, OH, at every other carbon atom. In the final step, this diagram shows how the borate ions react with the hydroxy groups on the polyvinyl alcohol chains. This forms bonds with the boron atoms that link chains together. The bonds connecting the chains are called cross-links. This diagram explains why the liquid glue becomes rubber. In the liquid state, the polymer chains are free to slide past each other. After cross-linking, by using the borate ions to link chains together, the polymer chains cannot easily slide past each other, so the material becomes more like a solid, but flexible like rubber. Now it's time to do the experiment. First, make a saturated solution of borax by adding borax powder to warm water in a flask or beaker. Keep adding borax powder until you see particles of undissolved borax settled at the bottom of the container. By definition, a saturated solution of a salt has some undissolved solid. In the second step, pour 10 ml of water from a graduated cylinder into a small paper cup. Make a mark on the cup at the meniscus of the water level to show the 10 ml volume, then discard the water. Now pour Elmer's white glue into the paper cup until it reaches the 10 ml mark you made on the cup. Measure 20 ml of the saturated borax solution in a graduated cylinder and pour it into the paper cup containing the Elmer's glue and immediately stir the mixture with a wooden stirrer. Continue stirring until the mass becomes like rubber. Scrape it out with the wooden stirrer. It should form a round mass at the end of the stirrer. Place the mass in the palm of your hand and squeeze the excess liquid into a wastebasket. Now roll the rubbery mass between the palms of your hands until it becomes a rubber ball. You can even bounce the ball to show that it has flexibility. This experiment shows that liquid glue can be transformed into a rubber ball by a process of polymer cross-linking. This process was called vulcanization by Charles Goodyear in 1839 when he discovered that he could make rubber from the sticky gum of a tree. This presentation was produced as a public service to help middle school and high school science teachers develop experiments, presentations, and demonstrations that can be used in their classes. More science experiments and demonstrations are available on the Tops of Santa Clara Valley website, www.topsofscv.org. Tops, Teaching Opportunities for Partners in Science, is a program aimed at stimulating greater interest in science by middle school students.